Alright, so this question asks us to use the mesh current to solve the circuit. Things all the impedance already have been converted to frequency domain. So this is actually one exercise for the mesh current method. If you forget about that, you can go back to the textbook to have a review. This question also can serve as a review as well. So first we're gonna give some reference current direction. For example, this one we can call I1. So this current called I2. This one goes this direction called I3. So this one goes this way called I4. Okay, and what we're gonna do is to sum for each loop all the voltage. Okay, so the voltage, the current flow as voltage drop means positive. So this is a current multiply impedance, and plus the minus this one, because this is not a voltage drop, this is a voltage rise, because the current flows into the negative and out from the positive. All right, so we can write that one first. So for the first loop, we have negative 10, 0 degree, and a plus. For the current flow, this capacitor is I1 minus I3, because I1 go to different direction, right? I1 minus I3, the current multiply with a impedance, and we're gonna plus the last one, which is I2 minus this one I1 minus I2. Okay, I1 goes down, I2 goes up. Okay, and multiply with the impedance, just one, and this one equal to 0. Okay, for the second loop, this one you can see this one is I2 minus I1. So in this loop, we will assume I2 is positive. Okay, it's larger than I1. So this one minus I1 have the current multiply with 1, that's impedance, and the second one is plus a I2 minus I3, and multiply with a J, and last one, this one go into a positive, leave a negative, so we got a positive 5 volts. That's the second one, and the third one is we start from here. So this is I3 minus I4. So I3 minus I4 multiply with a 5 volts and plus I3 minus I2. This is I2, right? I3 minus I2, and we got this one multiply with a J and a plus I3 minus I1. Okay, that's the current difference, and multiply with negative J. Okay, and equal 0. All this sum up equal to 0. All right, so now we're gonna clear the term. Let's simplify a little bit. So I'm gonna bring this one to the other side. Then this one equals to I1. There is I1, right? I1, 1, and there is, sorry, this is negative J, so it's a 1 minus J. That's for I1. For I2, here is I2, so I'm gonna minus I2, right? This is minus I2, and for I3, this is plus. I'll be very careful. J I3, okay, and equal to 0. All right, and let me do this one. So I want to collect all the I terms. So this is negative I1, and then look at I2. This is positive. This is a J. So plus a 1 plus J I2, and how about I3? I have only one I3, so minus a J I3 equals to a 5. Okay, sorry, I made a mistake. So this one's very easy to make mistake, right? Here is a 10. But I'll bring this one to the other side. And for this one, if you can't do it at one time, and you definitely can just break it down so it will make less mistake. Oh, sorry, I forgot the last one. So the last loop actually just gave you one thing, which is as I4 equals to a 1, because that's the 1 amp goes this way. Okay, so we can replace that 1 with a 1 here. Okay, so we're gonna plus a JI3 minus a JI2 and a plus a JI3 and a minus plus JI1 equal to 0. Okay, I think we need to do it one more step, so just move this one a little bit down. Let's collect terms. I1, where is I1? I only got a 1 I1, so which is a JI1 plus I2. There is an I2, that's the only I2 we have, so JI2. We got a 3 I3, and this is a 5 J. Okay. Yeah, I made a mistake here, so I think this one, right? This is negative J, so we actually gonna minus this one. So if that's the case, the negative part is gone. So we're gonna plus 5i3 and equal to 0. Okay. Sorry, I think I made another mistake here. So this one should be negative 5, right? So because the 5 moved to the other side, and I forgot this 5 as well. So this should be positive 5. Oh, good. So be extra careful about these. Then we can make some. So there is a positive J3. There's a negative J I3. So I want to cancel each other. So what I can do here is, for example, I can do a 1 plus 2. Okay, I do a 1 plus 2. I will get this positive gone. So I will get a. Let me have a look. So what I get. Okay, I get a negative JI1 plus JI2 equal to 5. Okay, I call this one a number 5. Okay, and what I also can do, so for this one I want to cancel this one. All right, so so far I have a 3 equation. Okay, so we have 3 equation, the simplified version. We have a 3 equation, 3 unknown, so you can solve the problem. Okay, if you don't want to see this, you can solve it all by yourself. You can jump to the end. Otherwise, you can see how I did it. All right, so it's very easy to mistake when I prepared this. I spent like 30 minutes because I made a mistake in the middle, and you know, it's not matching the result. By the way, the if you see a PDF solution for this subject, for this textbook, this question's solution is wrong. So yeah, do have a look your answer, double check it. Okay, so you can see that for 2 and 3, we're gonna use 2 and 3 to build another equation which only including I1 and I2. So we want to cancel I3. So in order to cancel I3 here, I need to multiply this one. So the second one need to multiply with 5j. Okay, 5j to multiply with that, and I want to use that one minus a number 3. Okay, so this one gonna gives us let me have a look what we got. And So if you're not sure, you better do it step by step. Okay, this is negative 5j minus just j, so it's actually negative 6j. Okay, negative j6i1. All right, gonna do it one by one very carefully. All right, this is for i2, and I will get a negative 5 minus j25. Okay, that will be equation number 6. Okay, let me do this. So after you have 5 and 6, oops, 5 and 6, two equation. All right, so from question 5, we can get the expression for I2, for example. So for I1, sorry, I want to, from this one, I want to get I1 equals to 5 minus j I2 over negative j. Okay, so from number 5, you move this one to the other side and divide it by that. Okay, and then you wanna plug it. So you wanna plug it into number 6. All right. So I'm gonna plug it in. So you have 5 minus j I2 divided by negative j, multiply with negative j6. Okay, that's the first part, and you're gonna plus negative 5 plus j6 I2. Can I shrink a little bit? So this one actually equals to negative 5 minus j25. Okay, so you move terms, collect all the I2 together, and then you will find that in the end I2 equals to 7 plus j5. All right, that's the thing. That's the first current you can get, and you bring this back to this number 5. So you can see this I1 equal to this about I2, right? So you can find that I1 actually equals to 7 plus j10, and I3 gonna equals to just 2. Okay, so if you got all of this, then you just look at this circuit. You can find that IA equals to I4 minus I3, that is negative 1. Then IB equals to I1 minus I3. So we got I1, we got I3 is 5 plus j10, and IC equals to I2 minus I3 equals to 5 plus j5, and ID equals to I1 minus I2, which equals j5. Okay, so that is the final solution. Okay, let me shrink a little bit so you can see the whole picture here. All right, that's it.